Hello and welcome to Module 11. In this module we'll be talking about ocean currents, specifically the patterns of circulation, the thermohaline circulation, and El Niño southern oscillation. So to start off, this is a picture of the currents and how they oscillate in gyres. And I'd like for you to take a moment to compare 10.6 to 11.1. So here's 10.6. We went through that in depth earlier. What happens, what's the difference between these two? What do you notice about this? What would the currents be like if there were no continents? Well, the currents would more closely resemble the prevailing winds like you see in this picture. Instead of having clockwise and counterclockwise gyres, the water at the equator would move continuously west, and water in mid-latitude regions would move more continuously east. And this would result in the formation of gyres at the poles instead. And a gyre just quite literally means circular. So a gyre is this circular picture here. And I have another video for you. It's called Current Gyres and Float Symmetrics that I'd like for you to watch. It's just a really good, it's another teacher doing the same kind of video, but his is really good. So I'd like for you to watch that. All right, let's move on to upwelling. Upwelling is when it happens mostly on the west coast of most continents, and the surface currents go down and brings up an area of cold water. And actually, we live in an area of upwelling, and it leads to much colder water, which is not real fun to swim in, but also an abundance of nutrients, and it attracts a lot of aquatic life. That's what makes our ocean so great for snorkeling and scuba diving and also fishing. So when we're looking at the thermohaline circulation, what this is saying is that thermohaline circulation means that as water gets colder and also saltier, it starts to sink. And the reason it gets saltier is due to freezing at the poles and then evaporating at the equator. So remember that salt water doesn't freeze or evaporate, so the salt is left behind. And then as it sinks, it creates this another gyre. And I have another video to show you of that I'm going to try to attach right here. Here. Okay, and finally, the El Niño southern oscillation is caused by a shift in ocean currents. So what this is telling us is that for some reason, the winds that normally blow from South America and push surface waters into the west, for some reason weaken and or change directions. So let's look at this chart that I've made for you, and I'd like to fill this out. So in a normal condition, the wind direction would be east to west. And the wind strength would be, I'm going to say medium. The precipitation location would be the West Pacific, Western Pacific. Ignore that, it just means my cookies are done. The water temperature in Eastern Pacific would be very cold, but the water temperature in the Western Pacific would be warm. And this, obviously no change from the normal because we're talking about normal. So then if we talk about the El Nino conditions, now the water is going to be going from west to east. So it's going to change directions, and it's going to have very low wind strength. The precipitation location will now be the eastern Pacific. So that's why when we had an El Nino conditions, we noticed that even in our country, the eastern side of the country had much more precipitation as a result of that, and we became very hot and dry. The water temperature in the eastern Pacific will be warm. Western Pacific, also warm. So the change here that we're talking about is that the surface waters change direction and warm water flows to eastern Pacific. I'm going to write all of that. Change direction. All right, I have more to talk to you about for the El Nino, but we will talk about it in class. Thank you.